Unit 18, part 11, sorry about that. It's an x over here, so this should be x in the consequent, which means when I'm doing the inverse of instantiation, this x becomes a. I had that incorrect, I think I had a y there. I kept that as a y, that's a mistake. So that's an a. This is the universal generalization, do the instantiation backwards. That's an a, it's f a. Right? The y goes to b, it's f a b hook g a. Right? So again, so the consequent of that, and I said the conditional proof, that's g a. That's what it should be. Okay, oh, and also, crucially, I've missed that, right? The antecedent of this conditional is this universal statement, and I missed putting that universal quantifier there. I blame my son, he distracted me. No, it's just because I'm testing you. You're Top Gun. You should have seen that, and I hope you were all shaking your heads at several points throughout the previous part. Okay, so that should be the setup, working backwards, getting the form correct, getting all these instances right. Right, so here we've got to get from FAB to GA, and then we're done, right? Conditional proof, UG, conditional proof. Okay, so this is one is a universal statement, right? The first assumption for the CP, that's a universal. So we're going to universally instantiate from it. We're going to do a UI replacing the X with what? So matching's involved, matching, right? We're going through A, B, and C for the proofs. We spoke at length about the importance of matching. What is the instance that I'm replacing X with? It's going to be A, because we want to have an F, we want this FAY to become FAB eventually. So the first position has to be an A, that's the one we're replacing now, right? But there exists a Y, FAY, hook G A. Yes, okay, which is also more matching going on. This GA matches that GA. So, right, we can sort of see the way home from here. We've now got a conditional justification, universal instantiation, A for X from 1. We've now got a conditional, and the consequent of the conditional is what we need to get home, right? And actually I don't need to blow this up, FAB, so notice this move, right? I need the consequent of the conditional, I can get it by modus ponens. What formula do I need to apply modus ponens? It's 2 premises for modus ponens. The conditional, of course, is one of them. The second premise is the antecedent of the conditional. I need the antecedent of the conditional to perform the modus ponens here, right? And look at what it is. It's the inference from FAB to, there exists a Y, FAY, EG, oh, what? No, that's fine, right? Yeah, that's fine. E.g. B for Y. Yes, I've done an existential generalization. I assume this, that's fine. So I thought I needed to blow it up. I thought I needed to match that. I'm an idiot, right? No, from that, yeah, I universally instantiated from 1 to get this, and so this is the move I just made, right? From there to there. From FAB, how do I use that? Right, I existentially generalize to, right, so what have I done? I've replaced the B with a Y and added the quantifier. Think of it in terms of, process it for meaning, you'll see it's clearly a valid inference. If, right, this is 1, 2, 3, 4, so this is EG on step 4, think about that. If A F's B, right, if A stands in the relation of F to B, then there does exist a Y, there exists some Y such that Andrew stands in the relation F to that Y, right? If A F's B, then there is someone that A F's. Yes, it's true, right? This is an existential generalization, unrestricted rule. We got there, right? And that's the antecedent for this. So modus ponens, conditional proof, you can annotate the proof from there. Sorry, that was so labored.